Hi, I'm Kees Jongenburger and I want to show you how to download MINIX3 on a Linux machine, Ubuntu, and install it so it runs on the ARM emulator emulating BeagleBoard XM. I'm going to show you the different steps and I'm going to try to do this within 12 minutes so I can publish the video. I'll create a directory demo. I'm going to clone the MINIX Git repository. Right, this is my normal way. I would have to insert a password, so I'm going to clone the master repository of Minix into a directory called source. This can take a while, depends on your network. We're quite a fast network here, so it should be alright. This contains almost everything actually in here. What we're going to do is that we're going to configure our ARM build to target the BeagleBoard XM. So usually I do this by copying the release script to a file called settings. And I just grab what's left there. Right, so this configures the most important flags of for the build. And I'm gonna launch the build right away using this script. The steps I describe here, you can see them on the Minix website. It's called Minix on ARM. And well, important thing to remember is it only currently works cross-compiling on 64-bit machines. And the steps are described here. So cloning the code, configuring your settings, calling the ARM SD image, and we're going to look in a moment what it actually does. Sorry. Yeah, that's a good one. And then start the emulator. Well, this takes, I think, about 10 minutes, so I will need to do some things in between. I might have to pause the video. Right. Let's look at the release script. Right. So the first thing is it does parse the settings file we just created, and then configure some defaults. So the default architecture, which is used later on in the cross-building script. I'm going to show you that later. The object directory where every output file is put and object files are put there. The build directory. Amount of parallel jobs you're going to do. If you put it higher and you have a good server, it will be faster. That's the basic settings. Well, the configuration, default configuration. We depend on a very few external tools. There's a few more, but those ones are especially for the ARM build. The build is self-contained. We're first going to create a cross-compiler, compile a cross-compiler, and compile the rest of the code using that. So, yeah. We download U-boot from directly as binary from our website. It's GPL code, and we don't want to include it right now in the source tree. And then we call the cross-building script with the argument distribution. The cross-building is not something we created. It's from NetBSD. It's also described in this guide, Developer's Guide Cross-Compiling. You can cross-compile Minix to x86 or to ARM, and we have two flavors of ARM currently we support. Yeah. So after this, in the object directory, there's going to be a compiler. There's going to be your kernel is going to be compiled. Your service is going to be compiled, and it's going to be a directory release there, something like that. That will contain a whole source tree, a binary tree of a root file system. So that's quite good afterwards to create the file system. Next is we create a flashable SD card image. So the idea is that we create a file that contains a partition table, the partitions that are needed by the operating system, in this case the Beaker board. It requires a FAT partition as first partition, where you put the bootloader in, the kernel and the modules and some other configuration. There's other ways. If you use eMMC 4.1, you can put that data in a different area on the SD card, but we're not using that right away. We generate an environment ourselves for U-boot that tells it actually to load the kernel, load the modules in the specific areas. Then we create a flat image, flat binary of the kernel, so the elf gets converted into a file that directly gets loaded to memory at the right place by U-boot and can execute in place, and there it will do the dance of enabling the MMU and things like that. The servers we installed are the memory management, reincarnation server, the scheduler, and other systems here. The memory drive contains a RAM disk, which is gets booted at first before the MMC gets loaded, and I think the MMC driver is actually in the RAM disk. So that's all on the FAT partition, and the rest is just code to create 3 partitions: a root partition, and home, and a var or a user, sorry, and create an image there. We're still building here, so I'm gonna pause for a minute. All right, let me see. Yeah, restarted. So the compilation now finished. I have an image, everything as well. I have an image here, the SD card image. And you can see a few partition in there. I can show you. Oh, I'm just gonna start it. I have my script. Actually, that's the same thing as what you can follow from the guide. ARM guide you've got here, and then we've got some pages about running on Linaro, QEMU's Linaro. We need to check out a certain version and compile it, and here are some flags you can use to start it. So let's start it. Now it's U-boot loading. It reads its script, it loads the different modules, starts the kernel, mounts the file system, and is ready. Yeah, power off can be easy if you don't want to have broken file systems afterwards. I think that's it. Thanks.